Here we have another example of permutations. We will look in how many ways can the sprinters be ordered. And we must remember that in permutations, the order is extremely important. We look at a number of examples, and one of them is going to be that there are no restrictions. In the second example, we want B to sprint last. In the third example, we want D must not sprint last, and C must sprint either first or second. And lastly, we've got an example where A must be followed directly by B. Let's start with the very first one, where there are no restrictions. If there are no restrictions, we can set up a table with 4 positions. And remembering that in permutations, the order is very important. We have 4 sprinters, and in the first position, any of these sprinters could be the first. And this leaves 3 sprinters to go into the second position. So I can put 3 in the second position, which in turn means that there are only 2 sprinters left, and those 2 sprinters can go into the third position. And lastly, the remaining sprinter will need to go into fourth position. Consequently, the total number of permutations will be, using the product principle, we just multiply 4 multiplied by 3 multiplied by 2 multiplied by 1, and that ends up being 24 different permutations. In general, when there are no restrictions, we can use a formula. This formula can be used to calculate the number of permutations, where n in this case is the number of sprinters. So I'll just write sprinters here. And k refers to the number of positions. Okay, that's going to be hard to fit in. And hopefully you understand that exclamation mark, it refers to a factorial number. And so using this formula, we have 4 sprinters, so it'll be factorial 4 over n being 4, take away the 4 positions, and that's all factorial. And if we expand this, we will get 4 times 3 times 2 times 1, and we divide it over 4, take away 4, which is 0 factorial. Please be aware that 0 factorial is equal to 1. That's the rule. So in this case, we can now further calculate this, and that will be 4 times 3 times 2 times 1 is 24 over 1, which is 24. And this is the same number that we worked out above. And in this second example, we want B to sprint last. That's this little fella here. And we'll work it out in the same way by drawing a table. And we'll fill this table. Now we know that the 4th position must be B. So there's only one person that can fill this position. So we'll put 1. Now we can go to the first position. We've eliminated B, so we now have only 3 sprinters left. So we will write that the first position can be occupied by any of the 3 sprinters. Now in the second position, we will have only 2 sprinters left. So we can write that as number 2. And in the third position, we only have 1 available sprinter. And using the product rule, the total number of permutations is therefore 3 multiplied by 2 multiplied by 1 and again multiplied by 1, which only leaves us 6 different permutations. In this example, we don't want D to be last. So D could be first, second or third, but it may not be last. That means we've only got 3 sprinters to choose from for the last position. So we still go for the 4th position. There are 3 sprinters over here. Now, it doesn't matter whether D is first, second or third. So let's look at the first position. 1 position has been already taken. That's the 4th position. So we have only 3 sprinters to place. So the first position will be 3 sprinters. Now we've got 2 sprinters left. And lastly, there's only 1 sprinter. So therefore, the total number is going to, using that product rule, 3 multiplied by 2 multiplied by 1 multiplied by 3. And this gives us 18. 6 times 3 is 18. Good. Now, in this example, I wonder whether you feel confident enough to be able to do it on your own. This one's a little bit different because there is a word in here that's really important, and that's the word or. In the previous video, I said that when you see a word or, you need to do an addition. So that means that you'll be adding 2 different permutations. So we will need 2 tables. We've split them into 2, and we're going to find out first of all what happens if C sprints first. That will be in this particular table. And then we'll look at what happens if C sprints second. So what happens if C sprints first? That means that there is only 1 placing where C must sprint. And then we have 3 positions, 2 positions, and 1. Now, for the second, we're looking, therefore, the C must sprint second, so C must be in the second order. So for the first position, we have 3 places. Third position, we have 2 places. And 4th position, we have 1 place. And so the total number, it will be equal to 1 times 3 times 2 times 1, and we will add to that the second 3 times 1 times 2 times 1. Okay, so we have these 2 permutations which we add together, so that's 6 plus 6, which will be equal to 12 different permutations. If you've been watching until now and you found this explanation useful, then I would please ask you to hit the subscribe button and also the like button, because that really helps me get the videos further out to reach a wider audience. Okay, now we'll get to the last problem, and this one could be a bit of a challenge as well, so let me show you how to work this out. So here I'm going to be using 3 tables, and you'll say, but there's no or word here, so there is no plus. Well, this problem is slightly different. So if A must be followed directly by B, then you could have this combination where I will place A here and I will place B here. But at the same time, I could place A here followed by B here, or I could place A here and follow it by B here. Did you hear me use the word or? And so all these are an or positions, so that I can actually write down plus and plus because we've got an or here. Or this, I could have this situation, or I could have this situation, or I could have this situation. So what do we actually put down over here? So if A is going to be in here, there's only 1 position, B 1. Now we've got 2 left and then 1 again. Now in this particular place, we've got 1 here, 2 and 1. Here we've got 1, 1, and in the first place we could have 2, and then in the second place we could have 1. So our product rule, our total number will be 1 times 1 times 2 times 1 plus 2 times 1 times 1 times 1 plus 2 times 1 times 1 times 1, and that ends up being 2 plus 2 plus 2, which is 6 different permutations. So if you found this useful, then I would really appreciate it if you could subscribe to this channel so that you can get more videos of the same, and also tick the like button, because that gives me a better distribution of these videos to a wider audience. So I would really appreciate this. Thank you very much.